Okay, so let's just solve the quiz on an empty slide here. I'll go ahead and just put a text box out here. And we'll left justify this. Okay, so we're writing a function. This guy's going to live inside of that linked list class, maybe called count. It's going to return an int, so called int count. Can I make it not auto-capitalize stuff? That might end up not being, well, we'll just roll with it. Not going to be very much code. So int count like that. And then what we need to do is we need to go through and first off, we probably want to ask if it's the empty list. If you did everything else right but didn't handle this part, that would probably be okay. So if we say if this dot head is equal to null, that means we do not have any nodes in there, right? So we'll just return 0. All right, so that's only if head is equal to null. Otherwise, we're still cooking. If you do everything else right, you left that if off, that's fine. You did only this? Okay. Well, let's see what the rest of it. All right, so otherwise, if I'm still cooking, that means I have at least one node, right? This is going to be similar to what we wrote last time where we added something to the end, where we have to traverse the entire list. So we're going to create a node, maybe call cur node, and start this guy off at this dot head. So we'll start off at the beginning of the list. So cur node points to the same place as head points to. We're also going to need a count, maybe start that guy off at 0. So we haven't run into any nodes yet. And we'll say while, actually we want to go ahead and set this at 1 because we already did find 1. Cur node is the first one. So while cur node dot get next node is not equal to null. So as long as cur node has a next node, what do we want to do? We want to say cur node dot get cur node is equal to cur node dot get next node, and then count plus plus. Afterwards, return count. So that should be the entire thing. So this stuff up here just says, hey, if I have nothing in my list, return 0. Otherwise, let's go ahead and make cur node point to the same place head points to, so they both point to the front of the list. Then we'll go ahead and count that one guy we already found. So count starts off at 1. And then this while loop will keep going as long as cur node still has an next node. So while cur node.get next node is not equal to null, go ahead and set cur node to be his own next node to move it down the list. We're traversing it down the list. Each time through, increment count by 1. I found another one. I found another one. I found another one. I found another one. This while loop will finally end when cur node's next node is equal to null. At that point, we'll fall out of that while loop and we'll return count, which is the number of nodes we found along the way. Make sense? All right, so this should look pretty similar to add end. In fact, actually, this looks fairly identical to add end with the exception of when we wrote add end last class, if this dot head is equal to null, we just said head equal to the new node instead of returning 0 because we're returning a count this time instead of adding something to the end of the list. But if I'm dealing with the empty list, adding to the end is the same thing as adding to the front. Otherwise, I'm going to go ahead and just walks my list. All right, questions about this? So something along those lines would have been the solution to it. Okay, then homework assignment. Let's see. What were we supposed to do for our homework? Do who what? Huge integer, right. And just for addition and subtraction. And only positive numbers. Only addition. Okay, huge integers, additions only, positive numbers only. Okay, good. How did it go? Was it trivial? Pretty trivial. It should have been somewhat difficult. Somewhat. It was very difficult. So you're just putting on a strong face when you say, yeah, it's somewhat trivial. All right, so did I say you should be able to, input two numbers and then hit a button called add or something, and it should add them together, give you the result as a huge integer? Okay, just that's it? All right. So let's see, did I give you a starting point for that? So this is the homework 2 template. This was your starting point. All right, and let's see what this guy currently looks like. While that launches, I'm going to shut off the front light here so you can see this stuff a little bit better. Okay. So what does this program currently do? Was it not? We just, okay, so it should just be the hello world program then. Okay, gotcha. Okay, good. So we need to have the ability to enter stuff in for two different boxes, right? Edit text boxes. And did I say, so put the stuff into one box, put the stuff into another box, hit add, and it spits out the answer in like a text view, maybe? Okay. But behind the scenes, it's doing the huge integer stuff, right? Okay. So why don't we go ahead and we'll get the ball rolling. I'm going to go ahead and let's create our whole interface, but we'll just read in from one text box initially, one edit text, just to get some stuff in and test it before we actually do addition. Let's prove that the huge integer is working first, right? That is converting effectively a string representation of a number into a linked list representation of a number. All right, and my linked list right here that we wrote last time, we started off this guy, it's a node holds a payload of an int, correct? Okay, so we already have it set up to handle our integers for us. Good. All right, so let's go back into, here's my activity main. Let's get these things a little bit bigger here so we can see them. I'm going to go ahead and squeeze that stuff down, zoom in here, minimize this. All right, see that pretty good? Okay, so I'm going to go ahead and I'm going to just take out this text view, and I'll go ahead and I'm going to throw in, because I like to use the vertical linear layouts and stuff, so I'll go ahead and throw that guy in there. There's my vertical linear layout, and then I'll throw in a couple of edit texts. So this guy is going to be, it's going to be a series of numbers. So we'll actually go ahead and I'll do it as a single number pad. That way it associates the right keyboard with it. So you can just type in numbers. Doesn't matter. We're going to assume they put in the correct stuff, but I'll go ahead and do that. So there's our first huge integer. Here's our second huge integer. Then we're going to have a button. And then probably a text view beneath that that's going to have the answer in it. Something like that. All right, so let's go ahead. I'm going to put hints. We're going to call this guy oh, we call it huge integer, right? Huge int 1 ET for your huge integer 1 edit text. And we'll call this guy huge int 2 ET. Okay. Who? Yeah, I will. And then we're going to call this guy huge integer number 1 for the hint. This guy will be huge integer number 2 for the int. And then let's go ahead and make both of these guys centered. So we'll center the text there. We'll center the text here. All right, and this button will say add numbers. Oh, that's actually the ID. So we can leave that as just button. This guy will be answer TV for our text view for the answer. And we'll go ahead and center that guy too. And maybe just put an n/a right now because there's no answer available at this exact moment. Okay, so our numbers are going to be coming in. Let's kind of plan this out a little bit. So a huge integer is going to be a linked list of ints where an input like 123 turns into the list 1, which links to a 2, which links to a 3. Now I suggested you might want to build it backwards, just cuz, right? that might be handy. There's a couple of things we can do. So we're going to process through this guy. We'll start with the empty list. So if I hit the 1 first and I add that to the front, so I hit the 1, then I add the 2 and I add 2 to the front. Then I hit the 3, I add 3 to the front. I'll end up building it backwards, correct? And that's probably going to be the easiest way to do the math. Make sense? Because when we do our math, we're going to deal with, this is the least significant digit first, the 3. Okay, so let's get our list built first. We already have a linked list that allows me to hold ints. Now I just need to process those individual ints and always add them to the front of the list and then ask the list to display itself, and we'll know we read the number correctly. All right, so we'll go back into here. Let's go ahead and give myself a, call this add numbers for that button. Let's give ourselves a function for that guy. So we'll go back into main activity. I'm going to create a public void on add button pressed. You can call it whatever you want, but I'm going to name this guy on add button pressed, and he's going to take in a view, v as a parameter. All right, and what's this guy going to do? He's going to read in from my edit texts. So what we could do in here is we can give ourselves access to our edit texts and make them kind of global variables inside of this function. So we could say private edit text, huge int 1 et, private edit text, huge int 2 et. And then here inside of onCreate, we'll go ahead and set those. So we'll say this dot huge int 1 et is equal to the edit text version of this dot find view by ID r dot ID dot edit, what do we call it, huge int 1 et. This dot huge int 2 et. All right, third time's the charm. No, nailed it. All right. This dot Or do you think I was mad at you for laughing at me?
No, I was also wondering why it wasn't working.
No, it wasn't working because I was hitting it multiple times in a row. I seem petite, but I actually have quite large in real life. I hit the buttons funny. I was, but on this keyboard, they're really tiny buttons. Like I'm not sure what I hit, but it wasn't just one button to begin with. I hit multiple buttons, and I'm not sure which ones. D that huge int 2. There we go. All right. See, I had to be more careful that time, otherwise she was going to shame me. Okay, so now I have access to those two dudes. So we're going to go ahead and we're going to get the string version of the first guy. So huge int 1 is going to be equal to this dot huge int 1 et dot get text. And the text is going to come in as an editable. So I'll just convert it to a string. So we'll go ahead and have that guy. And I'll do the same thing with the other one. To this dot huge int 2 dot get text dot toString. All right, so I'll get both of those guys as strings, but now I need to convert those strings to an int. All right, so I'm sorry, into a linked list. We already have a linked list that we can use. So we built this guy last time. Linked list seemed to work okay, blah, blah, blah. So we're going to use our linked list. We're just always going to add to the front. So what we're going to need to do is we're going to have to process a string. So for instance, if this was the string that was in that edit to huge int 1 edit text, I'm going to have to walk through the string one bucket at a time. So this string has a length of whatever the string's name is, dot length. This is the 1 is at bucket 0, the 2 is at bucket 1, the 3 is at bucket 2. But what's the those guys are going to come out as chars. I don't want the char version. I want the int version of those guys. So I'm going to have to convert that char to an int. Okay, so a couple different ways we can do that. I think we looked at this last class, right? We did some conversion stuff, right? You can use parseInt. parseInt will do it easy enough. We can also use index of to pull this off. Yeah, I can give you the string 0 through 9 and say return the index of this char. So the char 0 lives at bucket 0, char 1 lives at bucket 1, so on and so forth. So pick your poison, but so we're going to go ahead and we're going to say convert huge int 1 to a linked list. So we're going to say for int I is equal to 0, I is less than huge int 1 dot length, I plus plus, so this will spin through every bucket in huge int 1, and we're going from the beginning to the end of this guy. So I want to always add to the front of my linked list so that my linked list is getting. So I'm going to go ahead and create linked lists for these two guys. So we're going to go ahead and we're going to say linked list. Let's see. We call it L1. All right, fair enough. Linked list L1 is equal to a new linked list. We'll have linked list L2 is equal to a new linked list. And right now we're building L1. So we'll say L1 dot add front, and this guy takes in an integer as a parameter. What integer am I going to give it? I'm going to give it integer dot parse int, the empty string concatenated with huge int 1 dot char at bucket I. So this guy right here is a char. I'm going to take that char, I'm going to concatenate it onto the empty string. So this will give me the string representation of one character. Make sense? Because integer.parseInt takes a string as a parameter. So I'm going to give this guy this string representation just so you see how this works. If this was the char 2, and I concatenate that onto the string, the empty string. This will give me the string 2. Make sense? Remember, Java is a string-based language, so if we can get things into the format of a string, it becomes pretty easy to do these things. So this is one thing. I could write it this way. I could also write it L1.addFront both of these guys will do the same thing. Here's the string representing all of our decimal numbers, 0 to 9. This guy's going to be a single char, and since we know we're dealing with base 10 numbers, that will be a char that's either a 0, a 1, a 2, a 3, or 5, all the way up through a 9. So I'm going to say index of. What does index of do again? The position, the location of the first time it sees that char. So the first time it sees a 0 is at bucket 0. The first time it sees a 1 is at bucket 1, at bucket 2, at bucket 3, at bucket 4, at bucket 5. So we're using the nature of index of here along with a very specifically formatted string in order to convert chars into ints. Make sense? So these two lines do the identical thing.
For the second one, wouldn't it give you the position of it?
Yeah. What bucket, what position in this string does a 0 live in? At bucket 0. Where does a 6 live in this guy? What bucket does that 6 live in? Bucket 6. Strings are indexed from bucket 0. So, for instance, if I, just to clarify this, if I had the string hello, the H is at bucket 0, the E is at bucket 1, bucket 2, bucket 3, bucket 4. The 0 is at bucket 0. The 1 is at bucket 1. The 2 is at bucket 2. The 3 is at bucket 3. Make sense? So we just leveraged the fact that we knew how index of worked, and we just created a very, very, very specifically formatted string. This would not work if I just randomly put the 0s through 9 in here. They need to be in that order. I need to ensure that the char 0 lives at bucket 0. The char 1 lives at bucket 1. The char 6 lives at bucket 6 in order for that mapping to work. So these two lines solve the same problem. They convert the char into a integer. Similarly, we can, if you want to play Unicode math, just looking at different ways of solving the same problem. Unicode number 48. Let's see where those guys live. All right, so it is position 48. So just subtract 48 from it, and you'll have your decimal number. So another way of writing this is L1.addFront. The int version of huge int. Actually, we don't even need to get the huge int, the int version. We can. Yeah, I think the math will work. Huge int 1.charat I minus 48. Like that. That'll do the same thing. Because now I'm doing math with Unicode. The number 0, the char 0 is Unicode value 48. Minus 48 will give me the number 0. The Unicode value for 1 is 49. Minus 48 will give me the number 1. Make sense? None of these are more right than the other ones. These are just different ways of getting to the same result. Probably the easiest of these is this guy, the first one. Convert it to a string and then use integer.parseInt. Might as well use the tool we have for squeezing a number out of a string. All right, so pick your poison. Punchline is we need to get the numeric version of that chart. Okay, any way you cut it, we need the numeric version of that chart. Here, I'll leave these alternates in here commented out just in case you want to look at them when I push the. And we could probably come up with some other strange ways of converting. Those are kind of the most straightforward ways that I'm considering, but we could do other ways. I'm sure there's. Well, yeah, possibly, but I guess the point I'm really trying to drive home here is I want you to maybe move away from searching for a correct answer or searching for the correct answer. There aren't just the correct answer for most of these problems. In fact, it's for you, it's most important that you solve things the way that it makes sense to you. All right, that's why I'm showing you other things. When I show you 2 or 3 different ways of doing something, one of you might think that the first way makes the most sense. Another one might think the second way makes the most sense, stuff like that. When you're doing your homework, don't solve it the way that you think I want you to solve it. I want you to solve it the way that makes sense to you, because that's going to help me understand how you're thinking through problems. Over time, you'll get better at solving problems in a more elegant way. Nobody's impressed. A correct answer is a correct answer, regardless of how, poorly executed it is, something like that. Okay, so we're going to go ahead and add to the front of our list that guy, and then at the very end, I'm just going to go ahead and say L1.display. Let's just prove that we got our number in there correctly. All right, so now this is our on add button pressed. We need to go and hook that guy up over on the other side. So remember, this is MVC, Model View Controller. So for Android, this is how we expose a method to be used in on-click events in Interface Builder. Right, so by us writing this function here, when I then go into my Interface Builder here and I click on my button and I go to on-click, we now see, well, let me click off of it and back on it. It's not there. There it is. Just took a second for it to finish, for Gradle to finish building it. So there's our on add button pressed. So that guy got exposed to this side of things. That's how MVC works. Keep our logic and our interface separate, then give us some conveniences for getting those guys to connect back up when we need them to. All right, so as it is right now, I'm going to go ahead and put some number inside of this first text, edit text, hit add numbers, and it's going to print out to the console the linked list representation of that guy, proving I converted it into that. I'm not using the second edit text yet. So if I put in 123, I should get the linked list 3, linked to a 2, linked to a 1. There's 123. Print my numbers. I need to go to Android Monitor. There's my 3, linked to a 2, linked to a 1. All right, so we're good with that. Okay, so now let's throw in our logic to get the other number. It's going to be pretty similar to this guy. We don't actually need to display it. We know it's right there. So we'll go ahead and we'll convert HugeInt2 to a linked list. Okay, and this is another thing I still strongly encourage you to do, because one thing that you should be having difficulty doing, and I'm glancing at the quizzes, I'm going to see it. When you see me write code, it makes sense. When you have time to sit down and write code yourself, you can do Google searches, you can look at my code, you can kind of piece it all together, right? Okay, but now there's the disconnect. Okay, when you're asked to write something on the clock, it's discouraging, right? There's a reason why I'm giving you these quizzes. It's not punishment, okay? Because I want you to see yourself improve. Okay? your grades are not going to be as impacted as you think. If you've had me in class before, you know that I'm give very hard stuff, and then usually your grades work out better than they should. So as long as you work hard and show me you're putting in the effort, I think you'll see at the end of week 8, you've learned a whole lot of stuff. You'll have some bruises because you've been through the ringer, but in the end, you'll do okay in the class. All right, just go on the voyage with me and trust me. Okay. So, punchline is your weakness right now is when you have to write something. I mean, 10 minutes was plenty of time to write that in reality. I mean, you saw how long it took to write the code for it. But that's a sticking point for us right now. And part of it is, and this is why I want to continue to encourage you to do this, when you write your homework, cut and paste a minimum amount of stuff. Type as many things as you can yourself. Okay, even if it's the same stuff. Like right here, we could easily just copy this and make a few changes. Type it yourself. Because even though it's mindless or whatever, you're learning while you're doing that. And you're also giving yourself an opportunity to make mistakes that you're prone to make. All right, so I got fat fingers, so I'm prone to hit extra buttons or something like that. You'll kind of figure out what are your mistakes that you're prone to make. Do you forget semicolons all the time? Things like that. And you'll end up you'll make less of those mistakes because you'll constantly be fixing them. All right, that's part of the learning process is to write the stuff over and over again. Remember back to 535 when I teach that class, I really emphasize this idea that programming is like a sport. You got to just put in the reps to get good at it, whether, whatever your sport is, hockey or cricket or soccer, tennis, basketball, pick your sport. You can't just watch it on TV and get good at it. You can't just watch me sitting in front of the class and typing a couple of things and say, oh, that's all it was? It's not going to make you any better other than maybe make you feel worse about yourself, right? You got to put in the reps to do it, and you have to suck at it for a while before you get better. I always use golf as my example. So I'm an avid golfer, and I've played golf for about, 13 years now. And when I started, I was terrible. I would whiff. 9 out of 10 balls, I would hit on the ground. They wouldn't go anywhere. Now I'm pretty good by like most amateur standards. But there was a lot of reps in the middle. I hit a lot of golf balls, and I hit a lot of bad shots until now I hit some good shots, is what it comes down to. I want you to look at programming the same way.
So you never thought at any point that maybe golf is not for you?
Well, I mean, okay. If your question is, does that exist? The answer is yes. So, for instance, I think golf might be one of those sports that requires a lot of hand-eye coordination. Just in general. So if you're not somebody who feels you have real good hand-eye coordination, there might be a limit to how good you can get at golf. So kind of taking that on the flip side, if somebody's going to say, well, is programming for me? I think there could be similar type things. There's certainly people who are more predisposed to learning programming than other people. I think for most technology, if you believe that you belong in technology, programming is something you should be able to do it at some reasonable level. Maybe you're not going to go onto the PGA Tour and play professional golf, right? But you can. The idea is it's a mathy-based thing, it's a problem-solving based thing, but it's really a way of thinking, and it's the same way of thinking that you need to solve IT problems when you're problem-solving there. You have to break things down in those little baby steps. So programming is more of just a microcosm of that maybe slaps you in the face a little bit more often because there's no wiggle room, right? When you type this stuff in and it's not correct syntax, Java screams at you. There's not like, oh, well, that's not bad. Why don't you try this? No, it's wrong. That is wrong. That does not work. That's wrong. You spent 10 hours and I'm giving you nothing. You get nothing for your effort.
Yeah, those are the times that those thoughts kind of come in. It's like, after spending 15 hours, not like you don't want to spend this time.
I understand.
But at the end, so I'm just using that as a sign that before I do my assignments, is like, I want to do this. I want to start doing it. But like 5 hours in, I'm just like, maybe it's not.
The fact that you care means that you can program. So if it's bugging you that you're not better at it, the evidence would be, well, do you think it bugged me when I was whiffing the golf ball sometimes or hitting it on the ground. And you see some like 8-year-old girl 2 things over just hitting it way farther than you can. It's like embarrassing, right? That's where it really is like a sport. You can't just cram for it. You just have to put in the time. There's no replacement for time. And it sucks. I get it. But at some point, I promise programming will become fun. Right now, it's fun when you get something working, right? There's always that little joy, like, oh my gosh, it works. And then you got to go figure out, okay, what did I do? Why does it work? But eventually, you get to the point where you just sit down and you type it, and it just works. You make stupid little mistakes, things like that. And that's where it becomes more rewarding, when programming is fun and you can create. You have a good idea, let's just turn it into a solution to a problem. So if that sounds exciting to you, then you want to stick with it, but understand you're going to suck for a while, right? And you may not go pro. Okay? Just because you like basketball doesn't mean you're going to go play in the NBA. Okay? You might play the faculty league here at Concordia with other, middle-aged and older folks. All right. So punchline here is type as much stuff as you can yourself, because it will help you. It'll make you better. And at the very least, you can do that. Because there's going to be enough things that you aren't going to be very good at that will be frustrating, but you can type. So you at least got that going for you. So we're going to convert hugeInt 2. So we'll say for int I is equal to 0, I is less than hugeInt 2 dot length I plus plus. And we're going to be building up in L2 this time. So L2 add front, and we're going to be adding in a payload. So we'll do integer dot parse int. This guy takes in a string. What string? The empty string concatenated with hugeInt2 dot charat I. So now we'll build up our second string. Build up our second linked list. All right, so now we need to add. So let's think about what it's going to take to add. So anyway, so far so good. Read in 2 strings, convert them to linked lists. We're okay on that part? All right, so now, and the reason why I like giving this problem is, and these are the best problems for beginning programmers. Problems that you're like, I could solve this so easily in real life. Why can't I write a program to do it? Kind of know what I mean? You just add a couple of numbers. It's because it's the antithesis of that idea that we're so good at solving problems, we've forgotten how we solve them. So we have to go back and remember, how do you add 2 numbers together? What are you actually doing, like with the carries and that stuff? So, for instance, if I have the number, let's artificially create so I have 129 and 236, let's say. I'm going to add those together. So when we say 9 plus 6, that gives us a 15, right? So 9 plus 6 is going to be a 5 with a 1 carry. So we have a 1 up here now. Then we have a 2 plus 3, which is 5, plus 1, which is 6. No carry. Then 2 plus 1 is 3. So we have to conceive of that carry bit, right? Now, we only ever need 1 carry. Just an extra integer, and it's 0 most of the time. In this case, it was 1 the first time and 0 the other times, right? But we always add that carry onto our sum. Now, when we convert this into linked list format, so if we do the 129, this guy is actually going to look like a 9 linked to a 2 linked to a 1. And this guy will look like a 6 linked to a 3 linked to a 2. So now we can handle them from left to right. Maybe have a variable here called carry. And carry always reverts to 0 before we do an addition. So the very first time through, we're going to be pointing at the front of these 2 guys. We'll get the payload here, get the payload here. So 9 plus 6 is 15. 15 plus 0, the current carry, still 15. Is 15 greater than 10? It is. So we do 15 minus 10 and record our result as a huge integer. So we're going to have our result linked list. So this will be, we're going to take that, whoa, what? See, these are the errors I get. Fat fingers. There we go. I can program just fine. I can't, it's just the normal stuff I can't do. All right, so now I'll have my 5, and this guy's going to link to something else soon. But because I had something that was greater than 10, I'm going to carry that. So my carry gets set to 1. Okay? Next, then we move both our pointers over. 2 plus 3 is 5 plus 1 is 6. Then we can go ahead and say, is 6 greater than 10? It's not, so there's no carry. So we'll reset our carry to 0. We'll record the 6. Move our pointers. 1 plus 2 plus 0 is 3. Is 3 greater than 10? Nope, so no carry. Move our pointers. We are off the end of both lists now. Okay? But we do need to ask ourselves, do I have anything else to record? Well, the answer is no in this case because my carry is still a 0. Does that make sense? Now, let's play this out a little bit. So let's go back. I'm just going to change my numbers. So let's say this is 929. Just to fake it. All right. So this number was actually 929. So 9 plus 2 is 11. Plus 0 is still 11. Is 11 greater than 10? It is. So we're going to have a carry. 11 minus 10 is 1 with a carry. So then we walk off the end. I'm not done though because I do have this extra carry bit here. So I drop that down to the 1. Make sense? And then my answer here is actually the other way. It's 1165. So 929 plus, is that right? 1,000. No, that's not right. We did some early math wrong. Yeah. Let's just back up here for a second. I changed my number in the middle. So 9 plus 6 is 15, carry to 1. 3 plus 2 is 5. Plus 1 is 6. That's correct. Then 9 plus 2 is 11. So that's going to be a 1 carry the 1. Why is this math not working out right? $15.61. Oh, I'm adding it to the wrong side. That's it. So when we get to the end here, we have an extra carry. Well, that extra carry is actually on the far other end because of the way we've been building it. So really what we should do is we should build our result up like this. I'm going to do add front on my result. So we're going to say 9 plus 6 is 5. Carry the 1. 3 plus 2 is 5. I'm sorry, 9 plus 6 is 15. Yeah, so it's 5. 3 plus 2 is 5, plus 1 is 6. So it's going to be a 6 linked to the 5. Then we're going to have, I guess it doesn't necessarily matter how we, well, let's just keep going this way. Then we're going to have 9 plus 2, which is 11. So that's going to be a 1 linked to the 6, linked to the 5. And then our last carry will go on to the other end because it's an extra thing left over. So we'll tack it on to the end of it. So 1,561 will be our number backwards. So I'm not sure we actually bought ourselves anything by building it backwards there. It didn't really help. So we would just add that final carry bit to the front. All right, so that's what we do with an extra carry. We'll add it to the front. Now, what if my numbers are, let's do 9297, something like that. And that 7 actually will go on that end, right? So now I have a 4-digit number and a 3-digit number. So we're going to do and this is 9297, those are the numbers. So we would do the 7 plus 6 first, and that's what, 13? So it's 3 with a carry. So that's 7. That was 7 plus 6 plus 0, which is 13. So that's 3 with a carry. 9 plus 3 is 12, plus 1 is 13. So that's 3 with a carry. So still a carry. 2 plus 2 is 4, plus 1 is 5 with no carry. 9 plus illegal position. This guy is going out to null. So 9 plus nothing plus 0 is 9. So 9533. Looks right. 9297, 297 plus, what was my second number? 236 is 9533. 9533. So we're going to have to keep track of when we have illegal positions in either the top or the bottom. That's when you have things that are different lengths. Make sense? All right. Did it matter whether my bigger number was the first number or the bottom number? The way we have them lined up, it won't. Because we always are comparing least significant digits first. But when we're done, when both of these guys are pointing to illegal stuff, okay, when my current pointer is null for both of them, I'm done with numbers, right? No more adding. But I do need to take one final peek at my carry bit and say, is there something there? If there is, I got to do something with it. I tack it onto the front. Okay, so let's go and write this. So we're going to do huge integer math. So I'm going to go ahead and let's write this just as in a separate function. So we're going to say, now I said, didn't I say make a huge integer class? Okay. So then what we're going to do here, just to make this look a little flashier, I'll go into my app, go into Java, go into this guy. I'll go ahead and right click. We're going to create a new Java class. We'll call this guy huge integer. And yes, I want to add that. I'm going to go ahead and click remember, so it automatically will add them to my Git repositories. All right, so there's my huge integer. I'm going to get rid of this comment thing up here. And my huge integer is going to keep track of a linked list. Maybe call that the number. And then we'll have our constructor for this. So public huge integer. This guy will take in a string num as a parameter. And he's going to go through and he's going to say this dot the number is equal to a new linked list. And then we're going to say for int I is equal to 0, I is less than num dot length I plus plus, and we'll say this dot the number dot add front. So we're going to actually build our guys in here. So this is the same logic we had in the other place. So I'm going to add to the front of this linked list called the number the value num dot char at. Actually, we're going to do integer dot parsent on that guy. That's the one we've been using. Integer dot parsent, the empty string concatenated with num dot char add I. Like that. All right, so now this huge integer will just pass the constructor of this guy our string that we read in from our edit text, and he'll go ahead and generate that huge integer for us. Make sense? So now what I do is when I come back out here to my main activity, I no longer have to do all of this stuff. Now I could just say huge integer, huge int1, huge integer, huge int2 is equal to a new huge integer passing it that string. Is equal to a new huge integer passing it that string. Here's my huge integer class, right? Isn't this the exact same logic we had before for adding? I mean, instead of calling it L1, it's called the number. That's just a linked list. Isn't this the exact same logic I did before for adding stuff to the front of that linked list for whatever string was passed in? I've just written it in a generic way now. So now, in order to create a huge integer, I just pass the huge integer's constructor some string. He will take that string. He'll go ahead and initialize his linked list to nothing, go through every element of that string, and add the numeric version of each one to the front of the list. It's all self-contained inside of huge integer. So now we have an object that knows how to hold huge integers. That make sense? All the same logic we had before is there. It's not like we've cut down the amount of code. Well, we did cut it down a little bit because we didn't have to write this stuff twice. We wrote it once and then used it twice. Here. This guy came in for num the first time. This guy came in for num the second time. I'm building two separate huge integers. I'm using that blueprint to build huge int1 and huge int2. This constructor is taking in this string. This constructor is taking in this string. Make sense now? The guys doing? All right, so now I have two huge integers. All the same logic is there that we had there a second ago. Okay, this is called encapsulation. Okay, we've hidden the details inside of our objects. It's the punchline of object-oriented programming. Remember in 535 we talk about the difference between procedural programming and object-oriented programming? What we just had here before with all the details there was procedural, right? I used to use the example about the telephone, right? Pile of wires is procedural. Well, now we have something that looks like a telephone. Those wires are still in there. Look, they're right here. There's the wires. But once I have all the wires hooked up right, we put it in a nice little plastic case. And then when we're looking at it out here, it looks so nice and pretty and simple. It's still a huge integer. Still holds all the stuff that it held before. All right, so now we're going to go ahead into the huge integer class, and we're going to teach a huge integer how to add itself to another huge integer. So we're going to have a public huge integer add, and this guy will take a huge integer as a parameter. Let's just call it huge integer I. And this guy will add this huge integer to I, producing a new huge integer. Okay, So this is huge integer is represented inside of this dot the number. I's huge integer is represented in I's dot the number. Two different linked lists, right? We have one linked list that belongs to I. We have another linked list that belongs to this, the guy who got called here. And we're going to add those two things together. So we're going to have our int carry, start that guy off at 0. Okay, now we're going to start walking our list from beginning to the end, knowing we're actually walking it from the end back to the beginning, but because we built our linked lists in reverse. All right, so wireless network appears to have been compromised. Nice. All right, so what we're going to, whatever. So now what we're going to say here is we're going to give ourselves 2 pointers. A pointer to the beginning of the first list. Yeah, the recording's not on the internet because I don't use Panopto. See, we're mandated by the university to use Panopto. It's part of our job. We have to use it. Yeah. I'm too big to move. So that's a thing. Okay. Yeah, it still records. It's a local recording. I just might not be able to upload it as quickly. Okay, so we need to have pointers to the beginning of our 2 lists, right? So we're going to say, let's look at our linked list here real quick, make sure we have, do I have get? So I have remove front, so this will give me the front of the list. And we probably don't want to destroy so I could remove front, and this is going to, and if I remove front, it's going to give me the first element of the list as an int. And then we can ask if see, the real problem with removing is then we're breaking our huge integers. I don't think we want to break our huge integers. So what I'm going to do is I'm going to give myself I think I want the actual nodes themselves. If it were me, I probably would have implemented huge integer from the beginning as a linked list itself. So the huge integer itself is a linked list. So you would actually be adding things to himself. Actually, let's think about that then. I think we could pull that off. So if we want to write this in good object-oriented manner, we would say class huge integer extends linked list. So that's going to extend our linked list. Then we need to go into our linked list, and instead of head being private, it needs to be protected. That way it's exposed to children of the class. All right, so when we use, so I'm kind of showing you an ideal solution here. Actually, why don't we do this? Let me show you the way that you could have pulled, you probably would have had to pull it off for the homework assignment instead of using extend, and then I'll show you an upgraded version to it. So let's just go the normal way first. So huge integer will be standalone. It's going to use a linked list to represent its integer. Fine. Now he's going to need the ability, he's going to have to be able to ask a linked list, how many elements do you have left? And maybe also get the current, get an element at a certain position. So we're going to go ahead and add our count that we wrote for the quiz today to this guy. So we're going to say public int count. So we're adding this to our linked list. Now, realistically, you could build a count into a linked list by every single time you add front or add end, you increment a number. Just say, oh, you just added something. Every time you remove something, you decrement the number. But we'll just calculate the same we did for the quiz. So we'll ask if this dot head is equal to null, return 0. We have no count. Else, we're going to go ahead and say int count is equal to 1. We must have found one thing. Node cur node is equal to this dot head, while cur node dot get next node is not equal to null. Cur node is equal to cur node dot get next node and count plus plus, and then ultimately return count. All right, so pretty inefficient because every single time we ask for the count, it's going to go through and calculate the whole count. It's going to traverse the whole list. But it's fine. The computer's doing the work. We don't care. Because instead of keeping track of a count as we add things, it's like, oh, you just added something to the front. Now we have one thing. You just added something else to the front. Now we have 2. Now we have 3. Instead, we're calculating the count every single time we want to know it. We have to go through and add it all up. Not the end of the world. Okay, so that's our count, and then we probably also want to be able to get the value at a particular position. Yep. So we're going to go ahead and say public int get at pause. We'll say int pause. All right, and we can go ahead and assume that they're giving us a legal pause for this instead of doing a bunch of error checking. So we're going to have to traverse our list up to that pause. So we'll say node cur node is equal to this dot head. We'll say for int I is equal to 0, I is less than pause, I plus plus. Cur node is equal to cur node dot get next node. Return cur node dot get payload. So that will be get at pause. Start at the beginning of the list. So we're pointing at the very beginning. Then say go keep. So let's say they asked for pause 0. This starts at the front of the list. I starts off at 0. Is 0 less than 0? It's not. So this fails right away. For loops are pre-check loops. So we do not do the body of this loop at all. So we returned cur node.getPayload, which is actually head.getPayload. But let's say they said pause 2. Give me whatever's at position 2. What's up? Yeah.
We were just having a discussion in my class, and we're thinking about
All right. So, yeah. So let's say I was saying pause 2. I want bucket 2. So 0, 1, 2, the third element. We'll start off at bucket 0. I is 0. Is 0 less than 2? It is. So cur node is now at bucket 1. I plus plus. So now I is 1. Is 1 less than 2? Yes, it is. Cur node now points to bucket 2. I plus plus. Is 2 less than 2? It's not. We fall out of the loop. We return cur node's payload, which is pointing to bucket 2. See how this guy works? So he traverses our list and gives us the payload at a particular bucket. It's not add, we're not adding anything yet. All we're doing is we're adding an ability to link list.
Yeah, but I mean like concatenating it to.
What do you mean concatenating it to?
I thought we're just trying to getting all the values of each, all the payloads at each node.
Yeah. But this, I'm just adding an ability to link list. Now I can ask a link list to give me the integer that lives at bucket 5. That's it. Don't add it to anything. Just I want that integer. We're not removing it. We're not doing anything else. At the very end, once I've pointed to the right node, we're just going to return his payload. He's still in the linked list. He's still exactly where he was before. We haven't disconnected him. We haven't changed anything. We just said jump from bucket 0 to bucket 1 to bucket 2 to bucket 3. Give me that payload because I need that number. So that guy, in conjunction with our count, will allow us to say how many times am I allowed to call get at pause. So if I know there's something has 5 elements in it, I can call get at pause for 0, for 1, for 2, for 3, and for 4. After that, it's no longer illegal. Make sense? So I just added some ability to my linked list. So we come back into huge integer now, and what I'll do is I'll just go ahead and I'll get the size of my 2 numbers. Okay, so I'll say int this count is equal to this dot the number dot count. And then int I count is equal to I dot the number dot count. Make sense? So now I have 2 local variables here that know how many elements are in each of the huge integers. Okay? And then we're going to have a int this pause will start off at 0. And an int I pause will start off at 0. Because in both of them, we're going to start off at bucket 0. Okay? So if one of my numbers has 4 elements in it, and in my bucket 0, I'm allowed to get bucket 0. Then we'll look at bucket 1. Is 1 less than 4? Yep. 2 less than 4? Yep. 3 less than 4? Yep. Is 4 less than 4? No, I'm not allowed to grab any more elements from that guy. I've already processed all of them. So now we have the information that we need in order to do our logic here. So we want to keep getting values and trying to do some addition as long as this dot pause is less than this count, or this pause is less than this count, or I pause is less than I count. As long as either of those numbers still have digits left, I want to be able to get the values. We go back to this guy. Even though I ran out of digits on this bottom number here, I still had 1 more left on this one. So as long as I have at least 1 number to take into consideration, I need to try to do math. Okay? So, while this pause is less than this count, or I pause is less than I count. Now, when we're in this while loop, we just know that at least one of our numbers still has digits left. We still need to check to make sure that we can grab a number. So we're going to go ahead, we're going to say int sum. We'll start sum off at 0. Now we're going to ask the question, if this dot, not this dot, if this pause is less than this count, that means I have another number for this huge integer. So I'll go ahead and say sum is equal to sum plus this dot the number dot get at pause this pause. And then I'll increment this pause after I've grabbed that number. So this will get the number from the next position, add it to my, this is just a local variable for my sum. So that sum is like me saying 9 plus 3. So when I add sum starts off at 0, 0 plus 9 is 9, plus 3 is 12, plus 0 is still 12. All right, so if I'm able to grab a number from this guy, go ahead and grab it, add it to my local sum, and then increment this pause. Then if I pause is less than I count, then sum is equal to sum plus I dot the number dot get at pause I pause, and then I pause plus plus. We know we're going to get into at least one of these 2. We would not be inside of this while loop unless one of these 2 if statements is capable of hitting. We might get into both. for a 3 and a 4-digit number back here, we're going to get into both of them the first time, both of them the second time, both of them the third time, and only one of them the fourth time, because we ran off the end of the other one. Make sense? All right, so this just tacks it onto our sum. Then we're going to say sum is equal to sum plus carry. All right, because carry started off at 0 the first time, but it might be something above that now. You'll see the logic for that here in a second. Then we're going to ask the question, if sum is greater than 10, carry will equal 1. Sum will equal sum minus 10. Make sense? We're carrying for the next time through this loop. Else, carry will equal 0. Just in case carry was previously a 1. We're going to reset it back to a 0. So we either are going to have a carry bit next time and subtract 10 from sum, or we won't have a carry bit next time and sum is good as it is. So if sum was 3, for example, is 3 greater than 10? It's not. So we should not have a carry. So we're not going to change sum in here at all, but we'll go ahead and set carry back to 0 so that the next time through we don't have a carry bit. So after we've gotten done with this little if-else here, sum should have the value that we want to add to our list.
It didn't matter that you already used carry before you assigned a value to it?
It had a value up here.
Oh, okay.
Yeah, I initialized it to 0. Okay. So now we just need to decide, now I have an answer, right? I have a sum. Do I add it to the front or add it to the end? Because we kind of did it both ways. I think we ended up adding it to the end, right? So we did a 7 plus 6 was 15 plus 0. Here, let's... 13, sorry. 13 plus 0, so that was the 3. And then we added, so we're adding to the end, right? So we did 3 with a carry. That's 12 plus 1 is 3. With a carry, 2 plus 2 is 4. 5 with a no carry. And then the 9 drops down. And then we read it backwards. 9, 5, 3, 3. Okay, so we would then, we'll need to walk through it to grab the values to turn them back into a string in order to get our answer out in our text view.
What variable is holding the answer? Do we have a variable?
We're going to put this in a huge integer.
Okay.
Actually, what we would probably do is we could just put it into a string right off the bat. It still needs to return a huge integer, but we can build huge integers out of strings. So I would build the string 3359. So it's going to be 3359 like that. And actually, let me just do... let's make that guy a 9 there. So it's going to be 3, 3 still. Then 9, 10, 11, 12. So that's going to be a 2 with a carry. So then 9 plus nothing plus 1 is a 10. So that's going to be a 0 with a carry. And then where does that extra carry bit go? That drops down to... yeah. Well, the string's not going to be a problem. We already know how to put it into a huge integer. But this does not look like the right number to me. Oh, I have bad values here. Okay, so this is
And 79999.
so this is 9997 and this is 236. So 9997 plus 236 is 10233, 10233. Yep. So we'll add the leftover thing concatenated onto our string at the end. So we're always adding to the end of our string here. Now, if I have a number that looks like this, really I need that to be reversed to build a huge integer out of it. So we should actually concatenate it onto the front. So as we built this guy, we should have built a 3, then a 3, then a and then a 0, and then a 1, like this. Because this is what my string needs to look like in order to build a huge integer, for me to pass that to huge integer. So as I'm building up my string with my answer, I'm going to concatenate onto the front of the string. All right, and that's not hard to do. We'll see that here in a second. Okay, so I'm here. Sum holds my current value. Let's go ahead and let's give ourselves a string for answer. Start off as the empty string. All right, so sum is the number I'm going to tack onto my string. So I'm going to say answer is equal to sum concatenated with answer. That's how I put it onto the front. So here's my number first. Here's answer, go after it. Make sense? So now, after this while loop is done, we have processed all of our values. Check the carry bit. We got to make sure we don't have one last carry. Okay? So with one last carry, I need to go ahead and tack that onto the front as well. So if carry is greater than 0 is equal to 1, however you want to say it. So if carry is equal to 1, then answer is equal to carry concatenated with answer. You probably don't want to do that if carry was a 0. Technically doesn't break the number, but it'll look weird. All right, so now answer has our final value, so we should be able to go ahead and say return new huge integer built with answer, because this guy's supposed to return a huge integer. Make sense? All right, then one last ability we need to throw into huge integer, even though it's a little bit of a backwards thinking since we just had it as a string. We probably want to go ahead and give ourselves the ability to convert a huge integer into a string. Maybe the fun way of doing this, the easy way of doing this, would have been to do something like this. Private string rep for string representation. And then in the constructor here, we'll say this dot string rep is equal to none. So before we actually convert it into the linked list version of itself, we'll go ahead and save the string representation of itself. That way we can always ask a huge integer to give us the string version of himself. And then what we'll do is we'll go ahead and say public string toString this dot string rep. So now we can always ask a huge integer to convert itself to a string, and it'll just return his string representation, which was what he was originally built with. Even though internally he's being stored as a linked list, we can convert him to a string on the fly, same way we just did before with the count and concatenation and all that stuff, or we could just remember that he was a string. All right, so this is what huge integer could look like. Let's go ahead and test this guy. So we'll go into our main activity now. We have our two huge integers. And we'll say huge integer answer is equal to huge int1 dot add huge int2. Answer will be our result. And then we need to go ahead and get our text view. And what did we call that guy out here? Answer TV. So I'll go ahead and give myself the private text view up here. Private text view, answer TV. We'll give myself programmatic access to that guy here. So this dot answer TV is equal to the text view version of this dot find view by ID r dot ID dot answer TV. All this stuff is from our testing from last time, right? It's just all linked list stuff. So we'll just go ahead and grab our 4 widgets that we need to deal with, and then we'll go ahead and say this dot answer TV dot set text equal to answer dot toString. That should be the string representation of that huge integer. All right, so let's see if we got this right the first time. Let me just double check something here inside of our add. Let's make sure we're always kicking the pauses forward. This pause plus plus, I pause plus plus. Carry always resets. Then we check carry at the end. Okay. Go ahead and run this guy. So we'll do 123 and we'll do 14. So that's 37. It's 137. We can make it bigger numbers. Let's we'll just test that for accuracy. Oh. There we go. So that's 1, 2, 3, 1, 2, 3, 4, 5 plus 1, 4, 1, 1, 1, 2, 3 is 1, 3, 7, 2, 3, 4, 6, 8. Perfectly, first time. Still waiting for my first error. All right.
Did you upload this before we do the other? Because you wanted to show how to extend the links and stuff.
Yeah, we'll do that too, but let's take a break first. So any questions about this version of it? Okay, so just stop that, and let's take a 10-minute break. Stretch your legs, whatever, and I'll get this uploaded.